Now we're going to try this example. So it says use 5 equal subintervals with left endpoints, midpoints, and right endpoints to find the Riemann sum for f of x equals x squared on 0 to 1. Okay, so Riemann sum, that just means we're trying to approximate the area underneath the curve x squared. So when I say curve, I really just mean function, right? It's a fancy way of saying function. So underneath the function x squared on the interval between 0 and 1. Okay, so that means I'm looking between 0 and 1, and I'm looking for the area underneath the graph of x squared, right? So that means I'm looking for this area in red. Okay. So to find that, I'm going to use some rectangles, right? Because I know how to find the area of rectangles. Okay. So I can construct these rectangles in different ways. Here we're being told explicitly that we want to use 5 rectangles. And then we're going to form the rectangles based on left endpoints, midpoints, and right endpoints, right? And I'll explain here what that means. So first we need to find what these subintervals are going to be. Okay, we know we need 5 of them. We need to find out what they're going to be. So the first thing you need to do is figure out how wide these subintervals are going to be. Okay, so to find the width of these subintervals, you need to think about what is the total length of the interval to start with, right? So we're starting out with this interval from 0 to 1. Its full length is going to be 1, right? So the distance from 0 to 1 is going to be 1. So this is 1. Okay. So for example, if this was the interval from 2 to 4, then the total length would be 2, right? Because to get from 2 to 4, that means 2. Okay. If this was the interval from 3 to 5, that would again be 2, right? So something like that. So the length of the full interval divided by the number of subintervals that you want, right? Number of subintervals. So in this case, we need 5 subintervals, so this is going to be 1 divided by 5. And if I look at the decimal form for that, it's just going to be easier to use here. It's going to be 0.2. Okay, so then I know the width of my subintervals should be 0.2. Okay? So if I try to write down now what the subintervals are, I'm going to get something like this, right? So I'm going to end up with starting out with 0, right? So I know 0 has to be the very first one and 1 has to be the very last one. Okay? So after 0, I'm going to move over 0.2, so that's going to be 0.2. Okay? And you can see I've labeled that here already. Okay, so here's my interval from 0 to 1, and I can break it up into 5 subintervals by hopping over a length of 0.2. Right? So we get this as our first subinterval. The next one is going to start at 0.2 and go to 0.4. Okay? The next one will go from 0.4 to 0.6. The next one will go from 0.6 to 0.8. And then the final one will go from 0.8 to 1. Right? So you can see these are my subintervals, right? So 0 to 0.2, that's this one. Here, this is this interval. This one is this one. This is here, and then this is here, right? So you can see I get 1, 2, 3, 4, 5 little subintervals. Okay, so these are the subintervals I want. And now I can construct rectangles, right? So first, maybe label it on here, right? So I've labeled these subintervals onto here, right? I put these points on here. Now we can start forming our rectangles based on these criterion. So the first one is left endpoints. All that really means is that I'm looking at these subintervals, and on the left endpoint of the subinterval, that's where I'm going to go up and meet the function, right? So here, for example, 0, I'm going to touch the function at 0. So here, notice, because the parabola touches the graph, touches the x-axis and the y-axis here at 0, 0, this rectangle is really not a rectangle at all. It's just a line, so it's not going to have any area, right? The first real rectangle we get is from this subinterval, where I touch on the left point of this subinterval, right? Left point right here, and then I draw this rectangle. Okay, this is the next subinterval, so I'm going to touch on the left of it, left endpoint, and then form this rectangle. This is the next subinterval, so I'm going to touch on the left endpoint and then form this rectangle. And then this is the next subinterval. I'm going to touch the function on the left endpoint and then draw this rectangle, right? So notice on each of these subintervals, so this is 1, 2, 3, 4, 5 subintervals. On each of those, I'm going and touching the function at the left endpoint, right? So the left endpoint of each of these subintervals, right? So if you look at these, this is the left endpoint, this one, this one, this one, and this one. And so those are the points that we're going to plug into the function, okay? So now we can do the calculation, right? So it says use these subintervals to find the Riemann sum for x squared on the interval from 0 to 1. So that really means that we're looking for an approximation to these areas. So we're looking for, an approximation to the area, approximation to area. Okay, so in this case, it's going to be looking at the areas here, 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 and here, right? So notice the width of all of these subintervals is 0.2, right? That was the width we got. So it's going to be 0.2 times, so maybe we'll do the first rectangle. So the first rectangle is this one right here. That's not really a rectangle at all. So this is the width of the rectangle times the length of the rectangle, or height in this case. So that's going to be 0. It's got a height of 0 squared. So that's going to give us 0, right? And then plus 0.2 times, okay, so 0.2, that comes from this length. And then this height is going to be this point, the left endpoint, plugged into the function. So I'm going to get 0.2 squared, okay? And then plus 0.2, I'm going to plug in that left endpoint. So now I'm looking at, here's the width, 0.2, that's this. And then the height here is going to be whatever the function is at this point when I plugged in 0.4, right? So that's going to be 0.4 squared, okay? Because I'm looking at the function x squared, right? That's why I'm just taking these numbers and squaring them, okay? So the next term is going to be plus 0.2 times 0.6 squared plus 0.2 times 0.8 squared, right? So notice in each one of these cases, I'm doing the width times the height of the rectangle, right? So for this rectangle, for example, the width is 0.2 and the height is what I get when I plug in 0.4 into the function x squared, right? So 0.4 squared. Okay. So now I get this for an approximation to the area, and if I do the calculation on that, I'm going to end up with 0.22. Okay, so you can go ahead and type that into a calculator and see what you get, and that's the number that you should end up with, right? So actually I made a little tiny mistake on that, so it should actually be 0.24. Okay, so we're going to do this again now with midpoints, right? So notice for this first problem, we really looked at these left endpoints, right, of these subintervals. So we looked at these points only, okay? So in the next case, we're not looking at those left endpoints, but we're actually looking at the midpoints to those intervals, right? So here I'm actually looking at this point, right? And this point, this point, this one, and this one, right? We're looking at the middle of those intervals. And if you try to figure out what numbers those should be, so this should be 0.1, this should be 0.3, 0.5, 0.7, and 0.9, right? So that's what we should get for these points, okay? Those are the middle points to each of these intervals, okay? So then when I'm drawing my rectangles, I'm going to look at those midpoints, right? So here are those midpoints. I'm going to go up to meet the function at those points, right? So I'm going to go to the midpoint, right? Go up to meet the function and then draw my rectangle with that height, right? So go up to meet the function, draw my rectangle with that height, right? So you can see that's how I'm forming each one of these rectangles, right? So each one now, instead of touching on the left point, is touching in the midpoint, okay? So if we try to approximate the area now, we're going to get the same width for everything, right? So notice before when I had this 0.2, it shows up in every term here, right? 0.2, 0.2, 0.2. So I'm just going to go ahead and factor that term out. Okay, so I'm going to write down the width of each of the rectangles, right? So that's going to be 0.2. They're still all the same width. And then I'm going to write the sum of the heights of the rectangles, right? So the first height of the first rectangle, which would be this one, is going to be what I get when I plug in 0.1 into the function x squared. Okay, so I'm going to get 0.1 squared, and then plug in the next endpoint, the next midpoint, which would be 0.3 squared, and then plug in all the rest of these, right? 0.7 squared, and then the last one, 0.9 squared. Okay, so this is now going to give us our approximation to the area. So if you punch that into a calculator, you should get 0.33. Okay, so that's what the area, if I find all of these little areas of these rectangles and I add them all up, that's what I should get, right? So notice it's not exactly the area I'm looking for because, look, I've got a little gap here missing, and then over here I'm actually overdoing it, overcounting here, right? So but it's close, right? It's actually going to turn out to be pretty close. Okay, so that's what we get when we use midpoints. So now let's look at right endpoints. Okay, so this time we're looking at the right endpoints of these intervals. So if this is my first interval, the first right endpoint is this one, right at 0.2. This is the next one, this one, this one, and this one, right? So these are the right endpoints to my subintervals. And again, I'm forming my rectangles by going to that right endpoint, plugging it into the function, and then forming the rectangle from there, right? So I get these. Notice now these rectangles aren't touching on the left, they're not touching in the middle, but they are touching at the right, okay? So the right endpoints. So now I'm going to take the little areas for all of these little rectangles, add them up, and that'll be my approximation, right? So approximate area. Okay, so once again, I'm going to write 0.2 for the width of each one of these rectangles, and then I'm going to add up the heights. Okay, so the heights of each of these rectangles I get from plugging in the right endpoint into the function. So I should get this. Okay, 0.6 squared, and then the very last one, so this is actually just the number 1 squared. Okay, so take all of that now, we're going to punch this into a calculator, and we're going to end up with 0.44. Okay, so notice that's going to be a huge, or I mean a pretty significant overestimate, right? Because we're looking at this area, and these little parts right here, those are counted in that area, so it's overdoing it, right? It's also counting all this stuff on the bottom. Okay,